Hello, this is part four of derivative test. So let's continue with 31. So 31 says the point of the curve y equals square root of 2x plus 1, at which the normal is parallel to the line y equals negative 3x plus 6. So if you recall, the word normal really means perpendicular, right? And yeah, so normal is equal to perpendicular. And then the word parallel means same slope, right? Okay. So let's find the point. So a point means a coordinate on the curve when y equals square root of 2x plus 1, at which the normal is parallel to the line y equals negative 3x. So what we got to do is find the derivative. First, I'm going to find the derivative of this. So let's take y prime. So how do you take the derivative of a square root? It's just 1 over 2 square root, and then our x is 2x plus 1. Times the derivative of 2x, which is 2, and then the derivative of 1 is 0. So if you put that together, you get 2 over 2 square root of 2x plus 1. And then what you could do next is get rid of the 2, so you have 1 over square root of 2x plus 1. Okay, so y prime is that, and then our other line is y equals negative 3x plus 6. And what is this derivative of this? That's negative 3. So the slope that's perpendicular to negative 3 is the negative reciprocal of whatever this is. So this is negative 3 over 1. So what would be the negative reciprocal? It would be negative 1 over 3, right? Right. So remember, normal is perpendicular, or you could think of it as the negative reciprocal. Okay. So now what we're going to do is set this. Whoops, this should be positive, right? It's the negative reciprocal, so it should be positive 1/3. We're going to set 1/3 to this derivative. And then go ahead and solve for x. So what I would do next is cross multiply. So 1 times 3 is 3. And then 1 times that is just itself. Okay, continue solving for x. So I would get rid of the radical by squaring both sides. Okay, so 3 squared is 9. When you square the radical, it just disappears. And then go ahead and continue solving for x. So I'm going to subtract 1. So 8 minus 1 is 8. Solve for x by dividing both sides by 2. And x equals 4. So they said find the point. We only have the x coordinate. To find the y coordinate, you simply plug it back into, you're going to plug in this x value into the original square root of 2x plus 1. So if you recall, we have y equals square root of 2x plus 1. To find the y coordinate, you simply plug in this x coordinate back in here. So 2 times 4 is 8, plus 1 is 9. So square root of 9 is 3. So your point is going to be at 4, 3. Let's move on to 32. If f of x equals parentheses 5x plus 1 squared times x plus 2 cubed, find f prime of 1. So how are we going to take the derivative of this? There's two options you can do. I think you could take, you could take the derivative using logarithmic differentiation, because they're both raised to a power. And then the other option is just simple product rule. Right? I'm going to do that. I'm going to use the product rule. So if you recall, the product rule is f prime of g plus g prime of f. Okay, so what is our f and what is our g? So I believe my f is this, and my g is this. So f is parentheses 5x plus 1 square. F prime is going to be, you just use power rule, so it's 2 times 5x plus 1 to the power of 1. And then you must take we're not done, we got to use a chain rule, so the derivative of 5x. You take the derivative of the inner parentheses, so the derivative of 5x is 5. The inner derivative of 1 is 0. So you put that together, 5 times 2 is 10. Then you get 5x plus 1. Okay. And then the g is x plus 2 cubed. So my g prime is going to be power rule, so 3 times x plus 2 squared times the derivative of x plus 2. So the derivative of x is 1. The derivative of 2 is 0. So this is going to be 3 times x plus 2 squared. Okay, and then you just put it in the product rule and you're good to go. Okay, so f prime is going to be f prime, which is 10 times 5x plus 1, times it by g, which is x plus 2 cubed, plus g prime, which is 3 times x plus 2 squared, times by f, which is 5x plus 1 squared. And oh, that's not our answer because they want f prime of 1. So I wouldn't clean this up anymore. I would just, because they want f prime of 1, just where we see next plug in 1, right? So it's 10, 5 times 1 plus 1. This is 1 plus 2 cubed plus 3, and then this is 1 plus 2 square, 5 times 1 plus 1 square. Okay, 5 times 1 is 5 plus 1, that's 6. 1 plus 2 is 3, that's cubed. That's 3, and then 1 plus 2 is 3 square. 5 times 1 is 5 plus 1 is 6 square. So when you put this all together, you should get an answer of 2592. Okay, that's your final answer. Okay, 33. 33, we have h of x equals f of g of x, and then g of 3 equals 5. G prime of 3 is 3. F of 3 is 1. Find f prime of 3. So what we have to do first is find h of x. Um, let's see. What do we know? F of 3, let's see, g of 3 is 5. Wait. So we know that this is, we got to take the derivative of this. So if h of x is equal to f of g of x, what would h prime of x be? Yes, you have to use the chain rule. So it would be, or this is exactly the chain rule. So it's going to be f prime of g of x times g prime of x, right? And then we must plug in 3. So step 1 and then step 2, plug in 3 for your x. So it's f prime of g of 3 times g prime of 3. And then we use what we have to fill in the blank. So g of 3 is 5 because that was given. So it's going to be f prime of 5 times g prime of 3. That's given. That's going to be 3. Uh, do we know what h prime of 5 is? Do we know that? I think. Oh my God. Yeah, it was supposed to be given. I didn't write this information. This is also given. F prime of 5 should give you 4. So that is given. That's not something I made up. So we just fill in our blanks. So f prime of 5 is 4. And then g prime of 3 is 3. So times by 3. Your answer is 12. So your final answer is h prime of 3. Let's move on to 34. 34 says find the linear approximation of f of x equals square root of x plus 3 at x equals 1 and use approximate for a to find f of 1.2. So how do we find the linear approximation of f of 1.2? First, you got to find the tangent line. Okay, so tangent line. So you have a point. They're saying that we have an x value of 1. They don't give us the y coordinate. So that's the first thing we must do. Find the y coordinate. So go ahead and plug in f of 1 into this function. That's 1 plus 3, just square root of 4, just 2. So we have a point at 1, 2, right? And then let's find the slope. So, oh wait, yeah, we find the slope. So we have y equals square root of x plus 3. So y prime is going to be 1 over 2 square root of x plus 3 times the derivative of x plus 3, which is 1. So that's going to be 1 over 2 square root of x plus 3. And then plug in your coordinates. I think we just have to plug in our x coordinate because I don't see a y. So it's 1 over 2 square root, and then replace x with 1. One plus 3 is 4. This is 2. Square root of 4 is 2. So it's 1/4. So we got to find the point that's tangent. So we're going to use point slope form. So we're putting in the equation of tangent line. So you use point slope form. So it's, if you recall, point slope form is y minus y1 equals m times x minus x1. So we have a point at 1, 2. We have a slope of 1/4. So it's y minus y1, which is 2. My m is 1/4. And then it's x minus x1, which is 1. Okay, step 2 is I'm going to use it to approximate. So if x equals 1.2, what should y equal to? Right, we're trying to approximate it when x is 1.2. So you just use your point slope form. So it's going to be y minus 2 equals to 1/4. And then all you got to do is replace your x with 1.2. Okay. Okay. So yeah. So this is going to be 4th, and then 1.2 minus 1 is 0.2. And then you have y minus 2. And you go ahead and solve for y. So what's 1/4 times 0.2? Not sure. So that's 0.05. And then you have y minus 2, and then you solve for y by adding 2. You get y equals to 2.05. Okay, so that's how you would approximate it. I would, first find the coordinate, right? Then I would find the slope to find the equation of tangent line, then put it in point slope form. And then once you have it in point slope form, you just substitute your x for 1.0. Okay, let's move on. The next one should be 34b. So 34b, they want you to this is related to 34a, but this time they want you to approximate 3.98. So we are given, remember our function was f of x equals square root of x plus 3. And our point slope form was y minus 1 equals to 1/4 times x minus 1. And what else? We got approximate. So to get square root of 3.98, you could think of it as square root of 3 plus 0.98, right? That's also the same thing as square root of 0.98 plus 3, so it's very similar to square root of x plus 3. So that means we actually are approximating 0.98, not 3.98. We're actually 0.98, 3. Okay, so so all we got to do is plug it back. So our equation was y minus 2 equals to 1/4 x minus 1, and we agreed that our x is really 0.98, not 3.98, right? So it's going to be y minus 2, and then replace x with 0.98 minus 1, and then 0.8 minus 1 is negative 0.02, and then you add 2, add 2. So you get y equals 1/4 times negative 0.02 plus 2, that is 1.995. Okay. Okay, let's move on. So number 35 says, use differentials to approximate square root of 9.3. So use differentials to approximate square root of 9.3. So first, what would be our f of x? So approximate square root of 9.3. I believe our f of x is going to be square root of x, right? And then I believe our x is going to be 9.3. Then we're gonna let x equals 9. Wait, x equals 9 because 9.3 is really close to 9 because we're approximating, right? So let's find our point. So it's going to be f of 9 equals square root of 9, which is 3. So you have a point at 9.3. Okay. Now what we'll do next is find f prime of x. So f prime of x is 1 over 2 square root of x. And we're going to replace our x with 9. Square root of 9 is 3, so that would be 1 over 6. So now we can use point slope form. Okay, so our point is 9,3. So it's y minus 3 because that's our y, and then my slope was 1/6. So it's x minus x1, which is 9. And then I guess you can clean up the solve for y, so FOIL the right side. So 1/6 times x is 1/6x. 1/6 times negative 9 is negative 1.5. Solve for y, so we're going to add 3, add 3. And you get y equals 1/6x, and then negative 1.5 plus 3 is positive 1.5. And then you plug in your x value 9.3. So this is like your f, so f is going to be so if you want, you can actually, you didn't have this you could have also written like this. It could also be expressed as 1/6 x minus 3 plus 3, right? Because -9 over 6 can be reduced. So f of 9.3 is going to be 1/6, and then replace x with 9.3 minus 9 plus 3, and that gives you 1/6. And then 9.3 minus 9 is 0.3 plus 3, which is 3.05. So the change from x equals 9 to 9.3 is 0.3. Okay, let's move on. 36. Find dy if y equals sin of 1 plus x squared as x changes from x equals 2 to x equals 2.03. So find dy if y equals sine of 1 plus x squared as x changes from x equals 2 to x equals 2.03. So what we're going to do is do a little bit of implicit differentiation. So we've done this before, so let's do implicit differentiation. So on the left side, what's the derivative of y in respect to x? It's always in respect to x or in respect to time, right? So the derivative of y or 1y is just 1, and then you must add that dy dx. On the right side, what's the derivative of this whole thing in respect to x? Well, you kind of have to use a chain rule. The derivative sign is cosine. And then you use the chain rule. So what's the derivative of 1 plus x squared is 2x. And then what you could do is, what can I do next? Is if you want, you could put the 2x in front of the cosine if it makes it easier. Okay. So they want you to find dy, so we must cross multiply or separate. So step 2, I'm going to separate or solve cross multiply to solve for dy, right? Okay. So this has a denominator 1, so 1 times dy is dy, and then this whole thing times this is. Okay. Then what I would do is, so we found dy, which is 2x cosine of 1 plus x squared dx. Step 3, plug in x equals 2 and allow dx. Okay, so we have our x is going to be 2, because our x changes from 2 to 2.3x. So so the dx is the change from 2.03 minus 2, which is 0.03. So what that means is that's our dx. Okay, so it's going to be dy equals to 2, replace x with 2, and then cosine of 1 plus 2 squared, and then my dx is 0.03. 2 times 2 is 4 cosine, and then 2 squared is 4 plus 1 is 5. And then 0.03 times 4 is, or if you put all this in the calculator, you should get 0.034. Okay, so that is how you find dy. For 37, use Newton's to solve for sine of x equals x squared in the interval 0 to 2. So we're use Newton's method. So the first step I would do is get everything on one side. Okay, so I guess I should move that x squared to the left. So it's going to be sine of x minus x squared equals 0. Okay. And then step 2, I'm going to so step 2 would set an f of x. So my f of x is going to be sine of x minus x squared. And then my f prime of x is the derivative of sine of x is positive cosine of x. The derivative of negative x squared is negative 2x. And then step 3, use Newton's method. Okay, so what is Newton's method formula? It is this: x to the subscript of n plus 1 equals to xn minus f of x over f prime of x. Okay, and then do we have our f of x, and I believe we have our f prime. So our f of x was sine x minus x squared, and my f prime of x was is cosine of x minus 2 of x. Okay, so that's going to be x of n plus 1 equals to xn minus parentheses f of x is sine of x minus x squared over f prime of x. Okay, and then the step 4 is find the midpoint of the interval. So if we're going from 0 to 2, what would be the midpoint? It's just the average between 0 and 2. So it's 0 plus 2 over 2, which is 2 over 2, which is 1. So my x naught is 1. Step 5, plug in until values repeat. So this is a tedious, annoying part. Step 5. Plug in until values repeat. So x1 equals to x naught minus, so let's find x1. So our x naught was 1 minus f of x was sin, and then you sin of x minus x. So you just replace x with 1. That's really sin of 1 minus 1 square over f prime of x. So it's f prime is cosine of x minus 2 times x. So that's going to be cosine of 1 minus 2 times 1. And you get, if you put all this in the calculator, you get 0.891396. Okay, continue. Okay, let's find x2. So x2 is 0.891396 minus sin of whatever this number is, 0.8936 minus 0.891396 squared. And then this is going to be cosine. So when you put all that in the calculator, you get 0. So unfortunately, this does not repeat. 0.876985 does not equal to 0.891396. We have to keep on going until they're the same number. I'm running out of space, so I'm going to put it on the right. So let's find x4. So x4 is the previous number, which is 0.876726 minus sin of 0.876726 minus 0.876726 squared over the sine of 0.876726 minus 2 0.87626. And when you do that, you get 0.876726, and that repeats, right? X4 repeats to your previous number, which is x3. So it repeats. So your x is going to be 0.876726. Okay. So yeah, that's kind of long. So that was using Newton's method. Okay, let's move on to 38. 38 says show that 3x squared plus 2x minus 3y squared equals 1 and 6xy plus 2y equals 0 are orthogonal. So what do you remember about orthogonal? It is perpendicular. So yeah, orthogonal means perpendicular or normal. And then perpendicular can also mean negative reciprocal. Okay. So how do we do this? Let's take the derivative of 3x squared plus 2x minus 3y squared, implicitly finding dy dx, right? We can do that. So we'll do implicit differentiation for this part right here. So what's the what's the derivative of 3x squared in respect to x? It would be 6x. What's the derivative of 2x is 2. What's the derivative of negative 3y squared in respect to x? It would be negative 6y dy dx. What's the derivative of 1 is 0. Then continue solving for dy dx. So what would I do is like maybe subtract 6x, subtract 2, you get negative 6y dy dx equals negative 6x minus 2. And then solve for dy dx by getting rid of this negative 6y. Okay, so uh, could we do anything can we get rid of anything on the top? Maybe like a minus? Okay, so if we do that, 2 negatives becomes positive, so your dy dx is 6y plus 2 over 6y. Okay, now let's take the derivative. Let's do implicit differentiation for the other one. So the other one was 6xy plus 2y equals 0. Let's do implicit differentiation. So how do you take the derivative of this? We must use product rule. So product rule is this: f prime of g plus g prime of f. My f is 6x, my g is y. My f prime is 6, my g prime is 1. So apply the product rule. F prime is 6, g is y, plus g prime is 1, f is 6x. Okay, and then what's the derivative of 2y in respect to x? It's just 2, and then you add that dy dx, which is 0. So this is going to be 6y plus 6x plus 2 dy dx, which is 0, and then just try to get dy dx by itself. So I'm going to subtract 6y, subtract 6x. This is going to be negative 6y minus 6x. And then get rid of this 2 by dividing both sides by 2. Wait, did I do this right? 6, product rule f prime, 6. No, I forgot to add this dy dx. Yeah, I kind of messed up. Okay. Okay, wait, so f is 6x, f prime is 6, g is y, g prime is 1 dy, so product rule is f prime. Wait, 1 dy, so f prime is 6, g is y, plus g prime is 1 dy, and then f is 6x. And then plus the derivative of 2y is 2 dy dx. This is 0. Okay. Now let's go ahead and clean this up and try to solve for dy dx. So 6 times y is 6y plus 1 dy. I'll put the 6x first. So 6x dy plus 2 dy dx. And then solve for dy dx. So we have dy here. You have to put a dx. Okay. Now what I'll do is solve for subtract 6y. And then over here, you can factor out dy dx. And then it's going to be 6x plus 2. And then you have negative 6y. And then get rid of this 6x plus 2 by dividing both sides by 6x plus 2. So your dy dx is negative 6y over 6x plus 2. Okay, so let's compare the both of the derivatives. What can we say? So the first derivative of the first equation was dy dx was 6x plus 2 over 6y. And then this derivative here is 6 dy dx is equal to negative 6y over 6x plus 2. What can you say? Basically the negative flip, right? This right here is the flip of this, and they added a minus, so they are negative reciprocals. So they are orthogonal. Okay. Uh, let's move on. Let's move on. 9. So it says find the equation of the tangent line to the curve y equals e to the negative x, which is perpendicular to the line 2x minus y equals 8. So perpendicular means orthogonal, right? This right here means orthogonal. Okay. So if y equals e to the negative x, and then you have 2x minus y equals 8, what I'll do is take y prime. So yeah, y prime. So what's the derivative of e to the negative x? It's basically e itself times the derivative of the power, which is negative 1. That's negative 1 e to the negative x. And over here, what I would do is first solve for y, then take the derivative. I'm going to subtract 2x, subtract 2x. Get rid of this negative 1 by dividing both sides by negative 1. So you get y equals to 2x, negative 8. And then take the derivative of that. So the derivative of 2x is 2. So it has to be perpendicular to this slope. So what is the perpendicular slope? So it's just the negative reciprocal of 2/1. So the negative reciprocal is -1/2. Okay. And then we set this to -1/2. So it's going to be negative e to the negative x equals -1/2. Okay, then what I want to do is solve for x. I'll probably have to take the ln on both sides. Before I take the ln on both sides, let's get rid of this minus here and this minus there. I think it'll be a lot easier when you take the ln. So get rid of that minus by dividing both sides by -1. So you get so this would be positive e to the negative x. This would be positive 1/2. Then you take the ln of both sides. So that's going to be ln of 1/2. And then over here, this would be ln of e to the negative x. And let's see, ln e cancels, you're just left with negative x equals ln positive 1/2. And then get rid of this -1 by dividing both sides by -1. I get negative, positive, negative ln of 1/2. That's not our answer. We want an equation. So what we could do is you see this minus here. Remember when you're expanding or condensing log, if you have a minus, that means it's like a power. So we can also rewrite this as ln of 1/2 to the -1. And then what is 1/2 to the -1? That's 2. Okay, so what now is we gotta find our point. Our point is so you could do either way. You could do ln of 1/2 to the -1 or ln of 2 for your x. Either way, it's the same answer. I'm going to just use ln of 2 for my x. And then my y was uh, positive 1/2. Wait, so how did we get 1/2? Because y equals e to the negative x. So that's going to be y equals e, and then it's going to be minus a minus ln of 2. 2 negatives becomes positive. So now you have e and ln cancels, and then wait, you could have used ln of 2, or you could have used negative. You could have used this one, negative. You could have also used x equals negative ln 1/2. Either way, you're going to get a y value positive 1/2. Okay, so that's how I got my y coordinate. This is my x. Now we just got to find the slope. So slope is going to be y equals negative e to the negative x. And then you just replace what your x or ln of 2, right? or you could use negative ln of 1/2. Either way works. So if I use, wait, so y prime, because we got to find slope. What's the derivative of negative e to the negative x? It is negative e to the negative x times the derivative of negative x, which is -1. So that's positive e to the negative x. And you get, so then you plug in your x value. So you can use ln of 2 or ln of 1/2 to the -1 because they're the same thing, right? Ln of 2 is the same thing as ln of 1/2 to the -1. They're the same thing. Okay, so if I use this value, it's going to be, let's see, two negatives become a positive. So if you plug in either of this, it should spit out, you should get negative e to the ln of 1/2. Okay, and what happens is the ln e cancel, and then you're left with 1/2 and negative, so it's going to be -1/2. That's my slope. Okay, so our final equation is going to be y minus y1 equals 1/2 equals to -1/2 times x minus ln of 2. My final answer. Move on. We have a word problem for 40. So it says a car is traveling at 4/5 kilometers per hour along a straight road. A traffic camera positioned 1 kilometers from the road is focused on the car. How fast is the distance from the car to the camera changing when the car is 2 kilometers from the camera? And then it also says how fast is the angle? How fast is the angle? Yeah, how fast is the angle from the camera to the car changing at the moment the car is 2 kilometers from the camera? So they're asking two things, right? Let's first find out the first thing. How far is the how fast is the distance from the car to the camera changing when the car is 2 kilometers from the camera? So if you kind of draw an image, you have this little stoplight, and it's like pretend it's like hanging down, and then here's your car, and then here's the radius. Okay, so what we got to do is we're gonna have to find dr dt. And then somehow this forms a triangle, and we got to just fill in the blanks. So this forms a triangle, right triangle. And this was given, this distance from here to here is 2. And then this distance here and here is 1 kilometers. And we don't know the radius. So let's find the radius before we go any further. We can use, since this is a right triangle, we can use Pythagorean theorem. So it would be 1 square plus 2 square equals r squared. Okay, so 1 square is 1 plus 2 square is 4 equals r squared. 1 plus 4 is 5 equals to r squared. Solve for r by taking the square root of 5, so r is square root of 5. Yes, this distance is 2, x equals 2. And so we know that x equals 2, that was given. And then the speed, they tell us that it's cars traveling at a speed of traveling at 4/5 kilometers per hour. So that's like a rate, right? That's like a dx over dt. And it's traveling 4/5 kilometers per hour. What we need to find is dr dt. And yeah, we kind of have like a circle. So we're doing some kind of implicit differentiation, and our other equation is going to be x squared plus y squared equals r squared. Okay, this is your x, this is your y, this is your radius. Since the camera isn't moving, it doesn't have a rate. Okay, so it's going to be x squared, and then our y was this distance, which was 1. And then since the camera isn't moving, it doesn't have a rate, so it's going to be r squared. Okay, then what I would do is do some implicit differentiation. So the derivative of x squared is 2x dx in dt. So in word problems in physics, we usually take the derivative in respect to time. So it's usually in respect to time or in respect to x. What's the derivative of 1 is a constant, which is 0. What's the derivative of r in respect to time? So that would be 2r dr dt. Okay, and then plug in what we are given. So we said that x was 2. And then we also know that our speed, or dx dt, is 4/5 kilometers per hour. So it's going to be like 2 times 2 times dx dt, which is 4/5 kilometers per hour, equals to 2 r dr dt. So you got to ask yourself, we are trying to solve for dr dt, right? It's asking how, first part question says, how fast is the distance from the car to the camera changing when the car is 2 kilometers from the camera? So that is a speed. And we already have one speed, which is dx dt. So we have to find dr dt. Okay, so we have, this is 2r dr dt. Over here, let's clean this up. What's 2 times 2 times 4 over 5? That is 4 times 2 times 2 is 4 times 4 is 16 fifths. And then our radius was square root of 5, right? We got the radius from doing that Pythagorean theorem. Mhm. Okay. So we have 2r dr dt. So this is going to be so what I'm going to do is solve for dr dt. So I'm going to get rid of this 2r. So to get rid of this 2r, I can multiply by the reciprocal 2r. Or wait, r is square root of 5, so it's 2 square root of 5 dr dt. And then solve for dr dt by dividing both sides by 2 radical 5, 2 radical 5. So when you solve for dr dt, you're going to get 8 radical 5 over 25 kilometers per hour. Okay, so that was the first part of the question. They were asking you how fast is the distance from the car to the camera, changing when the car is 2 kilometers from the camera. Now let's do part B. So they're saying how fast is the angle from the camera to the car changing at the moment the car is 2 kilometers from the camera. So again, they're asking for a speed because they're saying how fast. Yeah, so Berkey says how fast. Okay, so here we have this triangle. So like remember the stoplight and then this forms a right triangle like this. This they want to find out this angle right here. And we have the radius. This length here was given, it was 1, and then this, or 1 kilometers, and then this length here was given, it was 2 kilometers. Um, so yeah, x was 2. Uh, the speed was dx dt, which is 4 fifths. So what we're trying to do is find d theta over dt. So what we're going to do is, oh, and then our radius was given, we solved that, that was already square root of 5. How do we find this angle? So it is a right triangle, so we definitely use SOHCAHTOA. And I think you can get away with anything, any sine. You could do sine, cosine, or tangent because we have all the side lengths. We have this leg one, this leg two, and the hypotenuse radical five. So it will work for any. So maybe I'll do tan theta. If I do tan theta, which is opposite over adjacent, so here's theta. The opposite is 2, and then the adjacent is 1. And but let's stick with letters. This was x, and this is 1. Yeah, this horizontal distance is x. Yeah, I'm going to do with letters first. You'll see why. So what I will do next is, so they're not, wait, how fast? So they're asking for a speed. So yeah, they're not asking for this interior angle. No, they're not asking for this angle. They're asking for a speed. So I have tan theta equals x over 1. Um, you'll see why I use letters. This horizontal distance is x, this vertical distance is 1. And so we have tan theta equals to x. So what I would do next is take the derivative of each side in respect to time, always in respect to time. So let's start with the left. What's the derivative of tan theta? It is secant square theta d theta over dt. What's the derivative of x, which is 1 dx dt? And then what do I do next? I gotta find secant theta. So if you look back to your triangle, what is secant theta? Because we gotta find secant square theta. So secant theta is the reciprocal of cosine. So cosine is adjacent over hypotenuse. So secant theta would be hypotenuse over adjacent. So secant theta would be the hypotenuse is radical 5 and the adjacent side is 1. Okay, and then so secant square theta is basically the squaring the radical 5. So radical 5 square is 5. Okay, so secant square theta, we just saw that, that's 5. We have d theta or dt equals to 4/5. dx dt was given, it was 4/5, right? That was given. Now we got to solve for d theta dt. So get rid of this 5 by either dividing 5 or you can multiply the reciprocal 5, which is 1/5. So d theta dt is 4/5 times 1/5 is 4/25. And then it's radians per hour. Okay, so that is the second answer for the second part. Okay, let's do one more or a few more. Few more. Let's do one more word problem. Okay, so number 41 says oil is spilled from a tank, spreads in a circle whose circumference increases at a rate of 40 feet per second. how fast, so that's a speed, how fast is the area of the spill increasing when the circumference of the circle is 100 pi? So you can think of it as like, yeah, just think of it like it's growing real fast, right? If you deal with oil spills, they grow real fast. But if you can also think of it as you can think of it as like a pond, and if you never mind, that's a bad interpretation. So it this oil spill would look like this. Um, here's the ocean. Here's the water. So here's the center, and then it just starts to trickle, like some kind of ripple effect. It just grows, grows. It's like in a circle. Okay. Let's just list everything we know. They're saying that we have a rate of 40 feet per second. So wait, what formulas do we need to know? Our formulas are, so they're talking about circumference and area of a circle. So the circumference of a circle is 2 times pi r, and then the area of a circle is pi r squared. They also tell us that it has an oil spill from a tank spreads in a circle whose circumference increases at a rate of 40 feet per second. So that is a rate, right? 40 feet per second is a rate, and that's related to the circumference of a circle. So that 40 feet per second is your dc over dt, which is 40 feet per second. Uh, what we need to find is they're asking for another rate. How fast is the area of the spill increasing when the circumference of the circle is 100 pi? So that means we need to find our dA dt. And then they tell us one more thing. They tell us the circumference of the circle is 100 pi. So C equals 100 pi. So we'll use this. So we know that the circumference of the circle is C equals 2 times pi times r. And then we can replace C with 100 pi, right? And then I think we can find our radius from here. Yes, we need the radius. So I'm going to solve for my radius. So I'm going to divide both sides by 2 pi, and then you get 100 pi over 2 pi. The pi's canceled. 100 divided by 2 is 50. So radius is 50. But we need that. Why do we need that? Because it says how fast is the area of the spell increasing when the circumference of the circle is 100 pi. So because we are trying to find dA dt. So we got to find the derivative of the area of the circle in respect to time. So how do you take this? So the derivative a, the left side would be dA dt. Uh, what's the derivative pi r squared in respect to time? It would be, so you could think pi is a constant, so it's just power rule. So 2 times pi is 2 pi, and then dr dt. Because, yeah, dr dt because we're taking it in respect to time. And then I put a dr on the top because that's what we have in r, right? So we got to find dr dt. Wait, do we have any of those? Uh, I don't think we have any of those, right? Yeah, actually, we do. I believe we have, oh, wait, no, we don't. So, yeah, we got to find dA dt. We also got to find dr dt. And we also know that the circumference of a circle is c equals 2 pi r. So let's take the derivative of, what's the derivative of c in respect to time? That would be dc dt. What's the derivative of, what is the derivative of 2 pi r? It is just 2 pi. And then you add the dr dt. But this we know that dc dt is 40. And then we can solve for dr dt, so get rid of this by getting rid of this 2 pi. So dr dt is 40 divided by 2 is 20 over pi. So we found dr dt, but that's not what we really want. We really want to find dA dt. So here's, if you go back to this formula, dA dt is 2 times pi times the radius, which was given, right? Which was 50. And my dr dt was 20 over pi. Yes, dr dt is 20 over pi. So when you put it all together, you get 2 pi times 50 times 20. That's 2,000 feet square per second. Okay, so that's right. That's it. Okay, let's do two more and then this will be the fun. We'll be done. Okay, so let's start with 42. So on 42, you're probably confused. They're asking for a limit. I thought this was all about derivatives. It is. You'll see. So we got to find the limit as x approaches infinity of e to the x over e to the x minus 15. Well, if you try putting infinity for x, it's going to be e to the infinity over e to the infinity minus 15. So that would be infinity over infinity. Unfortunately, this is indeterminate form, so we can't use that. So what you're going to have to do is apply L'Hopital's rule. So the L'Hopital's rule is basically you take the derivative of the numerator and the denominator maybe once, maybe twice, or maybe 3 times until you get a real value. So let's take so it's going to be the limit as x approaches infinity. Take the derivative of the numerator. The derivative of e to the x is e to the x. The bottom, what's the derivative of e to the x is e to the x. The derivative of negative 15 is a constant. And what happens is ex over ex is just 1. So it doesn't matter what x value is, it's still going to spits out a positive 1. So as the limit as x approaches infinity, the y value is 1. So this is your answer. Oh, I think that's the last one. So yeah, we'll stop here. So if you need practice with some derivatives, check out this video. Okay, I'm going to stop here.